this last section for Chapter 1, Section 4, C, we're going to solve quadratic equations using the quadratic formula. So at this point, guys, you've realized we've solved quadratics a ton of ways, okay? So the first way, obviously, is factoring. And when we talk about factoring, we talk about when we factored out a GCF, and then we factored when A was 1, and when A was not equal to 1, also factoring by grouping, right? Then we said, okay, well, what if we can't factor the traditional ways, or what if you happen to have a situation where you don't have the b value, the bx, right? So the second way we said was using square roots. And typical way of doing that is when you have an ax squared and a c value or something like that, right? Where you basically don't have the bx term, okay? So then we said, okay, well, what if we can't factor the traditional way, and what if you happen to have a b value? Then what do? Well, 3 and 4 work all the time, okay? Now, that doesn't mean you want to use them all the time, right? You know, factoring works sometimes, using the square works sometimes, but 3 and 4 work all the time. The third method is completing the square, which we learned in the last section, and the quadratic formula, which is the one we're going to do now. So you might say, well, why don't you just learn one of the methods? Well, for me, completing the square, I use it when A equals 1 and B is even. So the quadratic formula, when A does not equal 1 or when B is odd. That's when I use quadratic formula. But again, these are not requirements. This is just me, my preference. You got to figure out what your preference is. So the actual quadratic formula is given as this formula right here. So notice it's negative b, or the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. So you're like, okay, wait. What is b, what is a, and what is c? Well, remember that when you have a quadratic equation in standard form, a is the coefficient in front of the x squared, b is the coefficient in front of the x, and c is your constant, the number that stands alone. But a, b, and c, you can only identify them once it's equal to 0. So again here, remember, I'm going to write the formula at the top. So again, remember that x equals minus b plus or minus the square root of b squared minus 4ac all over 2 times a. So when I get to a problem here, I'm going to look at it. Notice it's in standard form. It's equal to 0. So I'm going to identify my a, my b value, and my c value. Okay? So those are my a, b, and c. And now I'm ready to go. Now, obviously, this is a quadratic formula slide and lesson. So I'm going to always do quadratic formula on these. But if this was just a generic problem that I got on the SAT, I would say to myself, first of all, oh, it's a trinomial. Let me factor it. Product is 2, sum is negative 4, and I'm like, oh, wow, I can't get there. There's nothing that multiplies to 2 that adds up to negative 4. So I know I can't factor it. So this, personally, because this is even, right, and a equals 1, right, I would pick completing the square for this problem. However, again, because today we're learning quadratic formula, that's the method I'm going to choose. But for me, completing the square would be the way I would probably do it on an assessment or SAT or something. So again, x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And so again, I just very carefully, the opposite of negative 4 is 4, and I do negative 4 squared is 16, and then it's like having a negative 4 times a 1 times a 2, so that's a minus 8 all over 2. So here I go 4 plus or minus the square root of 8 all over 2. Now, again here, I'm going to simplify that radical. The square root of 8 is really the same as 4 times 2, and I know that the square root of 4 is 2. And so now you're here at this last part, and because 4, 2, and 2 all share the factor of 2, I can simplify. 2 goes into 4 twice, 2 goes into 2 once, and 2 goes into 2 once. And so my final answer is going to be 2 plus or minus the square root of 2. And that's my final answer. So again, the process is very straightforward. It's just a matter of memorizing the formula and plugging the numbers in correctly. So let's go to the second one here. Again here, yes, I would try to factor this. On a normal day, I would say, okay, what numbers multiply to... And so again, there's no numbers that multiply to -2 but add up to -3. So this one's unfactorable. Now, when it comes to a completing the square, notice that b is odd. And so this would be something where I would definitely use the quadratic formula for. That would be my preferred method on this one. So either way, whether it's preferred or not, remember, we're doing the quadratic formula every time here anyway. So I've got my a, b, and c. Notice it equals 0, so it's okay. I can identify my a, my b, my c. And then I just get to figuring out x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And so I'll just start chipping away here. The opposite of -3 is 3. I know -3 squared is 9. And then I have -4 times 1 is -4. And -4 times -2 is +8 all over 2. So again, I've got 3 plus or minus the square root of 17 over 2. And that's my final answer. So those are my two solutions. And now we get to down here, and we notice, wow, a is a fraction, b is a fraction. It's not even set equal to 0. So I might start by moving the c value or the 3 over here to the left by subtracting 3 to both sides. That way it all is equal to 0. Now, no matter what, we definitely don't want fractions. And so we learned in the past that if we multiply by a least common denominator, we multiply all the way across, right? Or a least common multiple, we'll be able to eliminate our denominators. And so if I multiply 2/3 x squared by 12, I'm going to end up being left with 4 times 2x squared. If I multiply 1/4 x by 12, I'm going to be left with 3 times 1x. And then if I multiply -3 by 12, it's going to be -36. And then 0 times 12 is 0. So I'm going to get 8x squared minus 3x minus 36 equals 0. And so now I'm ready to do my quadratic formula. Again, I'm not going to look to see if I can factor this, and it's definitely not one I would do completing the square, right? So quadratic formula would be my pick here as well. Again, my a is 8, my b equals -3, and my c is -36. So for this one, I'd probably get a calculator ready. It's going to be the opposite of b plus or minus the square root of b squared minus 4 times a times c, which is negative, all over, again, 2 times a, which is 8. So I come over here and I get +3 plus or minus the square root of 9 minus 115, or plus 1152 rather, because two negatives equal a positive, all over 16. I get 3 plus or minus 1161 all over 16. And when I'm trying to simplify 1161, if you add the digits in it, it equals 9. Well, guess what? That means that it's divisible by 3 and divisible by 9. And so I'll go 3 plus or minus 9 times 129. And then it's going to be over 16. And so again, it's going to be 3 plus or minus 3 square root of 129 over 16. And that's about as far down as I can go. So again, the number's not pretty, but the strategy and the process is the same. And so I don't know that I really entered the details, but why I know this is divisible by 3 and divisible by 9 is because if the sum is divisible by 3, then the entire 1161 is divisible by 3. If the sum of the digits is divisible by 9, then the entire number is also divisible by 9. So sorry about that. All right, we got a couple more problems, just a couple little tricks and things that happen that I want to make you aware of so you don't kind of fall for them. You know, notice in this one, it's out of order. And so that's important. It matters that you put it in order, because if you don't, then you're going to think this is B and it's not, or you're going to think this is C and it's not, okay? So it has to be in order for you to kind of do it. So it has to be in standard form. So ax squared plus bx plus c equals 0, right? And again, sorry, not c, 10. And so I see that A is 1, B is 8, and C is 10. So again, for me, I would try to see first if I could factor it. Completing the square would be a really good one here because, again, B is even and A is 1. But today we're doing quadratic formula, so x equals the opposite of B plus or minus B squared minus 4 times A times C all over 2 times A. So we get -8 plus or minus 64 minus 40 all over 2. X equals -8 plus or minus 24 over 2, which equals -8 plus or minus. Now 24 is 4 times 6, which is 2 radical 6 all over 2. And once again, because all three of these are divisible by 2, I could simplify those a little bit and get that x equals -4 plus or minus the square root of 6. And last but not least, we get to this last problem. And notice that initially you might say, oh, wow, this is a completing the square thing. I could do this and this, right? Nope. And the reason why we cannot do that is because completing the square would have worked had this x not been there. Okay, it only works when the other side is the constant, the c value. So unfortunately, I can't do that. So what I actually have to do is I have to FOIL this out. X squared plus 6x plus 6x plus 36 equals -2x. X squared plus 12x plus 36 is -2x. And I have to make this whole thing equal to 0. So I'm going to have to add 2x to both sides. So I'm going to end up with x squared plus 14x plus 36 equals 0. Again, I would try to factor it. If factoring doesn't work, I would definitely try completing the square here because A is 1 and B is even. But let's do quadratic formula yet again. Okay, so B is 14, C is 36. So x equals the opposite of B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. So x equals -14 plus or minus 196 minus 144 all over 2. So x is -14 plus or minus, again, this can be 52 over 2. And I can probably keep simplifying a little bit more, right? I got plus or minus 52, I know is 4 times 13. So 4 times 13 is going to be 2 radical 13 over 2, right? And then again, because all of these are divisible by 2, I know that this becomes -7 and these become 1. So my final answer is -7 plus or minus the square root of 13. And that's it. So that's the gist of it. So again, the important thing to note is when to use what. Obviously, your first thing to look for is to factor. If you can solve by factoring, that's going to be the best way. The square root method is going to be great in certain situations where you have no bx part to your problem, okay? 3 is you're completing the square. And again, completing the square works all the time, but I would prefer to use it when A is 1 and B is even, okay? And then 4 is your quadratic formula, which also works all the time. And I prefer to use it when A is not equal to 1 and B is odd, okay? That's my preference. So these are preferences right here that I'm listing, okay? These are my preferences, but they can be used all the time. The first two can only be used in certain scenarios, and so they're more limited, but they're much faster if they're applicable to your problem.